Hi, I am Anindam Mullik and you all are welcome to my channel Technical Audi, Live with Programming. Now, our today's topic is creation of the binary search tree. How can we create a BST from the given keys? We are see in this video. So, let's start with me. Now, this is some keys are already given here. This is the keys, okay? With the help of these keys, we are generating our binary search tree, BST. How can you generate? Now we are observe it. What is the procedure? How can you generate the binary search tree from using these keys? Let's see. Okay. Now, first of all, what is a rule? There is some rule. The first element, that means first key, is become the root of the BST. So what is the first element? That is 25. 25 is become the root of the BST. Now, now take the elements one by one. Take the elements one by one and compare with the root. Compare with the root element. Okay. Now, if the element is smaller than the root, so elements is become the left child or left subtree. Go to the left subtree. Now, if the element is larger than the root, that means the element become the right child or element go the right subtree of the root. This is the rule. Again I repeat, we are taking the elements one by one. Now if the element is smaller than the root, that means go to the left child or left subtree. Otherwise, if the element is larger than the root, so go to the right child or right subtree. This is the procedure. We can follow this rule, this procedure. Okay. Check. Take the 30. Compare with the 30. If you are compare with the 25. Now, which is smaller? 30 is bigger. 30 is larger than 25. That means 30 is go to the right child. That means right subtree of the 25. Now, take the next element. What is the next element? 28. Now, start from comparison with root. That means 25. 20 is larger than 20 is larger than root. That means go to the right subtree. Now, but here is already a right child of the 25. Now compare with this 30 with 28. 28 is less than 30. That means 20 is become the left child of the 30. Now, next element is 15. Now we are insert the 15 on this tree. Again compare with the root. 15 and compare the 15 and 25. 15 is lesser than the root. That means lesser than the 25. So 15 become the left child of the 25. Next element is 20. Now again compare with the 25. 20 is lesser than. 20 is less than the 25. So 20 is become go to the left subtree. Now here is on the left child there is an element. What is the element? That is 15. So we are now comparing with the 15 and 20. So 20 is larger than 15. That means 20 is become the right child of the 15. Next element is 22. Again we are starting the comparison with root. If you are comparing with the 22 and 25, 22 is less than the root. That means 22 is go to the left subtree now. But here there is a left child. What is the left child of 25? 15. Compare with the 15. 15 but 22 is the bigger. 22 is the larger than 15. So obviously go to the right subtree of the 15. That means the right child. But here there is a 20 is on the right child of 15. So we are comparing with the 20 and 22. But here we see that 22 is larger than 20. So 22 is become the right child of the 20. This is the procedure. Next element is 5. Again compare with the root. 5 is inserted. This is the procedure. Compare with the root. 25. 5 is lesser than 25. That means obviously 5 is go to the left subtree. Now, what is the left child? 15. Compare with the 15. if you are compared with the 15, 5 is smaller. So obviously 5 become the left child of 15. This is the procedure. Take the next element. This is 18. Now again we compare. 18 is smaller than 25. That means it is 18 is go to the left subtree or left subtree of the 25. Now what is the left child? Left child 15. Compare with the 15. 18 is greater than 15. That means 18 is go to the right subtree of this 15. Now compare with the 20, but because 20 is on the right child of the 15, so compare with the 20. 18 is smaller than 20. That means 18 is go to the left child of this 20. Next element, go to the next element. Next element is 35. You can insert the 35. Again you compare with the 25. That means root. 35 is larger than 25. So go to the right subtree. But here, what is the right child of 25? 30. Compare with the 30. 35 is larger than 30 also. So 35 is go to the right subtree. That means right child of 30. Now, last element that is we are inserted, that is 32. Now, compare. 32 is larger. 30 compare with the 25. 32 and 25. 32 is larger than 25. So obviously 32 is go to the right subtree. Now compare with the 30 and 32. 32 is bigger than 30. So obviously 32 is bigger, go to the right subtree of this 30. Now again, what is the right child of 30? 35. Compare with the 32 and 35. 32 is lesser than 35. That means 32 is become the left child of 35. So this is the procedure. This is our final binary search tree. Now, is it the binary search tree we are getting? We check. What is the procedure says? Always the left subtree, all the left subtree elements are smaller than the root. If you are check that 15, 5, 20, 18, 22, all are lesser than 25, that means root. And the all the right subtree elements are still larger than the root. Yes, 30, 28, 35, 32 is larger than 25, that means root. It is a BST. If you are checking on this here, that means 15, the left subtree, that is left child is 5. 5 is smaller than 15, yes. If I go to the right child, that means 20. 20 is the larger than 15, yes. So it is a BST. Same way, if you are coming here, 18 is lesser than 20, yes. 22 is larger than 20, yes. Sorry. 28 is a less than the 30. Same way, 35 is larger than 30. 32 is less than 35. Yes. So it is a binary search tree. So this is a procedure. This is our final binary search tree. But so now, so our discussion is completed. But I like to do a simplify for remembering this small thing. Now, I like to show you a easy way for remembering the how to generate the BST. What is the procedure? Just first of all, take the 25 as a root. Now 30 is bigger than 25. So obviously go to the right child, that is a bigger. Now next is 28. 28 is bigger than 30. Sorry, bigger than 25. That means go to the right subtree. Now there is a right child, that is 30. Now compare with the 30. 28 is less than 30. That means 28 is become the left child of 30. Now next is 15. 15 is smaller than 25. So obviously 15 become the left child of 25. Next is 20. 20 is less than 25. But if you are comparing with the 15, 20 is bigger than, larger than 15. That means 20 is become the right child of this 15. Next is 22. Insert the 22. If you are compare, 22 is lesser than the 25. Go to the left subtree. But it is 22 is bigger than the 15. So go to the right child. That means right subtree. Again you compare the 20. 22 is bigger than 20 also. So 22 is become the right child of 20. Next is 5. If you compare, 5 is lesser than the 25. Now we are so go to the left subtree. Now we are comparing with the 15. 5 is less than 15. That means 5 is become the left child of 15. Now next is 18. 18. 18 is smaller than 25. So go to the left subtree. Now if you are comparing with the 15, 18 is bigger than the 15. Go to the right subtree of the 15. Go to the right subtree. Now we are comparing with the 20. 18 is smaller than 20. So 18 is become the left child of 20. Next element is 35. If you are compared, 35 is bigger than this 25. So obviously go to the right subtree. Now 35 is bigger than this 30. So 35 is become the right child of this 30. Now last element is 32. 32 is bigger than this root. That means 25. Now we are comparing with the 30. 32 is bigger than the 30 also. Go to the right child. Now we are comparing with the 35. 32 is less than the 35. That means 32 is become the left child of 35. So this is the short way how can we create a binary search tree. I think it is a clear that how can we create a binary search tree from the given keys. I think it is a clear the rules, because it is very important. I think it is clear to up to you. Thanks for watching.